Good morning, students. Myself Shilpa Sharma, and I welcome you all in the series of digital system design. Today, we're going to discuss about generics, generate, packages, and library of VSDL language. In this context, in generic, first we will discuss about generics. The concept of generics in VSDL is used to design or parameterize or design. Can we write general models instead of making specific models with VSDL? Yes. Answer is what? Yes. With the help of generics, we can declare a constant object of mode. The value of this constant can be specified as a static expression globally. It is useful as the same design can be used by creating different instances, each having different parameter values. These parameter values, which differ in various instances of the same design, are called generic parameters. So, generics helps to generalize or design. The value of generic may be specified in an entity declaration, means in component declaration, and in component instantiation. The syntax for generic will be how? It should be written in the entity or in architecture like generic, under bracket, generic name, colon, its type, then it should be initialized. Like I have defined here. Look, I am writing a generic for AND gate. Before writing the whole program, means architecture, we will define its entity. In the entity part, we should know that how many number of inputs we are going to take. We can take 3 input AND gate as well as single input AND gate or 2 input AND gate. We should define that. Because according to that definition, we will specify the inputs. So one is the way, just write port A, B, C, D. If we are specified that AND gate is having 4 inputs A, B, C, D. But if we are not specific about the number of inputs, then we should generalize it to AND value. This AND value should be a natural number and the value can be initialized in the generic syntax. It can also be given somewhere else. Now look, in the entity part we have defined in a normal way like entity and underscore gate is. But after that we have specified a generic parameter that is of AND value, which is a natural number, and it is initialized to value of 2. Now in the port part we will define just a single value of A input but with a vector value of 1 to n. This AND value is specialized or specified in the generic syntax, which is value of 2. Now Z is the output and AND. Now in the architecture part, we will define simply by architecture, some name of architecture of entity name is begin, then process, we are applying the inputs. So we are working on input, that means A. Now we will define the whole working of that AND input, means AND gate can be specified in behavioral mode also. In that mode we need to apply a K loop. In that K loop, first we will work on single input, then another input, and previous input must be ANDed with the next input, then answer must be ANDed with the next input, and then it should be in a loop. Then after completing it, we will AND the architecture. So this way we can define and generic. Generic can also be defined in using this, means in component declaration and component instantiation, generics can be used. Look, in component declaration part, like we were doing in structural mapping, we were doing the port mapping. So in component declaration part, component NAND underscore gate is defined here, declared here. Here we can use generic also. As well as in component instantiation part, where we are doing port mapping, here can also be generalized the generic. So in three ways we can make the generic declaration. This was all about generics. Now we will move to the generate part. The generate statement simplifies description of regular design structure. Generate is a concurrent statement that is used to conditional and repetitive structures during the elaboration phase of simulation. It is used for repeating concurrent statements for a predefined number of times until a condition is satisfied. There are two forms of generate statement. These forms are for scheme level and if generate statement. Here I have defined the syntax for both these statements. Syntax for level is, first we need to define the label colon for parameters or for identifiers in range, then we will generate, then we will give concurrent statements and the generate label. If we are using for if generate scheme, then syntax will be how much? How will it look like? It needs to define the label, then we will define if with a condition of generate, then concurrent statements are specified, then we will end this generate with its label. So in this way we can define the generate. As you know, generate is for repeating concurrent statements for a predefined number of times. That's why we are defining it for generate. Or till a condition is satisfied, that means if generate is. Label is here compulsory to be used with the generate statements, and both forms of generate can be nested to any label. Range and condition included in for generate and if generate respectively have to be state, which implies they cannot be signal. We can define it through an example also, but before that we will proceed to our next terminal or next point of packages. What are packages? Packages are concepts introduced in VHDL allowing reusability and sharing of code across different design units by providing a modular storing mechanism. A package can be defined as a collection of components, functions, procedures, data types and other design units stored conveniently in design library, so that any piece of code required by any design unit can be called and reused from the stored module instead of required to be rewritten every time. A package can be shared across many VHDL models. These packages and libraries serve as repositioning of functions, procedures and data types. Here, packages are divided into, means whenever we are writing a package, it consists of two parts, package declaration and package body. These package declaration includes the definitions, functions, procedures. When working with the large design projects consisting of very small VHDL programs, it is convenient to have common procedures and functions in separate packages. For example, a package containing definition of new types for registers, instructions, memory, etc. will certainly be useful for microprocessor design. So in the package declaration, what we will write? For example, we are defining a XOR gate and compiled as a new entity. Now half adder, a full subtractor or full adder and a parity generator circuit needs to be designed separately using structural type of modeling, and these all entities to be designed require XOR gate as a component. So instead of writing code for XOR gate for each entity under design separately, a user can write, compile and store XOR gate design in a package ABC, and any entity which needs to use XOR gate can simply include the package ABC. To include it, we need to write package ABC, then entity colon XOR underscore K. And then we can use it any number of times in any number of entities to be designed in different design libraries. So, a package declaration is what? It contains information about what is available in the package that we can use in our VHDL program. Or in the other words, we can say that it contains interface or specification of the function and procedure that are available in the package. For example, what it returns, the type of input parameter, what is the type of returning value, what are parameters they take, list of functions and procedure. Now to declare it, we need a syntax. So syntax is how much? How will it look like? Package, then package name. It is user defined name, so you can write any name here. Is. Then we will declare the package items. These items can be subprogram declaration, type declaration, subtype declaration, constant, signal, variable declaration, file declaration, component, attribute, any type of use clauses. These can be defined in package. Then we will end this package and write the name of that package. So this way we can define the package. Now let's take an example. Suppose we are defining a package synthesis underscore package. In this I can define constant value, means which is low to high. This is a kind of time whose value is 29 seconds. In this package I am also defining type, means ALU underscore operation is, it can use add, subtract, multiplication, division, equalize. We can also attribute, we can also use a type MVL, means we can define unidentified value 0, 1 and high impedance state. We can also define the type MVL underscore vector, which is a kind of array. We can also define the subtype of this MVL or ALU underscore OP, or we can define a component also. So this is a part of package which value can be defined anywhere. But we need to take care that we need to specify this package in use clause, where we write use IEEE. We need also to write use work dot that package name dot all. So in this way we can configure, we can relate our package to our current program. So this is the way we can define the packages. Now if we talk about IEEE libraries, then what are these? Each design unit is analyzed and placed in the design library. Recalling that library are generally implemented as a directories and referenced by a logical name. This logical name corresponds to physical part of the corresponding directory, like implicit visibility. In VSDL, libraries std and work are implicitly declared, and explicit visibility is achieved through library clause, like use clause. Example, library IEEE use IEEE dot std underscore logic underscore 1164 dot all. So once a library is declared, all of the subprograms type declaration in this library become visible to our program through the use of use clause. So this way we can define the library. Generally, we used to define std underscore logic underscore 1164 library. In this library, generalized programs can be defined. All the required type, declarations, syntaxes are present in this library. So for now, thank you. Till then, stay tuned to our video lectures of DST.